Hi team, I'm recording our review now. So I wanted to get right into it. Your review is available on Brightspace, and here we go. Number 1 says, what is the molar mass of iron? So to look up the molar mass of iron, we have to look at our periodic table. I've got one with me, and iron is here, and you may or may not be able to see that. It says 55.845 and that top little red number, which is the mass. Now we're taking this to mean grams, but before we'd take that to mean the mass of one atom of iron in atomic mass units. So now when we take that number, we mean that number in grams is the mass of 1 mole. So when we're taking that off of the periodic table, we will take 1 decimal place. So that makes it 55 point. Now this says 84. And then a bunch of other digits. So we're going to keep the 5 and the 5 and the 8. We're looking at the 4 to say, do we go up or down? So we'll round off and say 55.8 grams of iron. You just need this final answer. If you pull it off the periodic table and you already know it's 55.8, you don't have to show all of your rounding, but there it is. Now, 1B asks us, how many atoms is this? So if we have 1 mole of something, doesn't matter how much it weighs or what the mass is, 1 mole is always 6.02 times 10 to the 23 of whatever we're counting. So we're counting iron, so we'll say atoms of iron, right? Number 2, what is the molar mass of chlorine gas? So chlorine gas is Cl, and it's a diatomic molecule, so Cl2. So when we look up the mass of chlorine on the periodic table, here it is. It says 35.45. 35.45. We're going to round that. We're looking at keeping 35 and the 4, and we're looking at the 5 to say whether we go up or down. So it's 5 and up, we're going up, so we'll say is 35.5. Now because we have 2 chlorines, we'll say 2 times 35.5 gives us, that gives us 71. And keep that 0.0 because you want 1 decimal place always, grams of Cl2 in a mole of Cl2. Now 2b says, how many molecules is this? Again, this is 1 mole of chlorine, so it must be 6.02 times 10 to the 23 molecules of Cl2. Okay. Number 3 says, what is the molar mass of aluminum chloride? So here we're adding things from the periodic table. It's AlCl3. Our aluminum has a mass of 26.9815. So 26.9815. We'll round that off. So we're going to say we're keeping those 3. We're looking at the 8. We're going up. So if we go up, 9 turns to 10. So we get 27.0, right? And I'm showing my rounding here. You don't have to do that, but just so that you know how it all works, let's pull that number from chlorine up from up here. Same rounding, same number. Chlorine is 35.5. Okay, so let's add them all up. Our aluminum is 27.0. Our chlorine is 35.5, and we happen to have 3 chlorines and 1 aluminum. So we'll say 1 of these and 3 of those, and we'll add it all up together to get a total. So, I don't know if you'll be able to see my calculator screen. Maybe not. Let's try that anyway. We've got 27 plus 35.5 plus 35.5. You can times it by 3 if you want, but there's 3 of them there. And I'm getting 133.5. I'll just do a double check here. Sometimes it's a handy practice to put things in your calculator twice. So that's what I got again. So 133.5 is, I'll give it a little underline, is our molar mass of aluminum chloride. This is A. So now let's look at B. Is again a molar mass, but this time it's ammonium carbonate. So that's NH4, and there's 2 of them, and CO3. Okay, so let's add all of those up from our periodic table. Here, don't forget that when we're counting, we need to pay attention to any numbers that are outside of the bracket. So here we actually have 2 nitrogens and 8 hydrogens, 1 carbon, and 3 oxygens. So if we look for nitrogen on our periodic table, here it is, 14.0. So I'll write 14.0, and there are 2 of them, so I'll give it a little times 2. Hydrogen, if you look on your periodic table here, is 1.0. So we'll say 1.0, and we'll say times 8, right? Because there's 8 of them. Carbon from your periodic table is 12.0. 12.0, there's 1 of them. And oxygen, here it's 15.999, and we're rounding up, so we get 16.0 for oxygen. And there's 3 of them. Okay, so to come up with your answer, you'll have to add all of those. And I'm getting 96 grams. All right. Next, it says, let's see, 4A, what is the mass of 1 mole of oxygen gas? So, if we look at, so oxygen gas is O2. If we look at our periodic table, it's 16.0, and we're rounding up there. So 16.0 times 2 gives us 32.0 grams for the molar mass of oxygen gas. How many molecules are in 2 moles of oxygen gas? Slide everything up for you. So we're looking at 4B. How many molecules in 2 moles of oxygen gas? Okay, so they gave us 2 moles of O2. We need to find some number of molecules of O2. So when we're doing this converting, it's handy to remember the statement, the number of moles times the number of things in a mole gives us the total. Okay, so if that's the case, we are given moles and we're looking for the total, so we can put in our number here and find out what the total is. So we'll say 2 moles times 6.02 times 10 to the 23 equals. So this should make a bit of sense. If we know that there's 6.02 times 10 to the 23 things in a mole, and we have 2 moles, it makes sense that we just double it. We multiply it by 2 to get our total. I hope it makes sense. If not, email me. Okay, so here we go. We'll say multiply it by 2 in your calculator, and you're using scientific notation, so we'll say 1.204 times 10 to the 24. And here we're counting molecules. This is a very large number, which makes sense because when we're counting molecules, we count them in big groups. So there we have it. Now, one last thing to pay attention to, we were given one significant digit. So when we do this kind of final step, and check our digits and check our units, we're going to want to round off to 1 digit. So we'll keep the 1, cut it off here. Looking at that 2, we're rounding down. So I'll say 1 times 10 to the 24 molecules of O2. Being careful not to shorten molecules to MOL or MOLE because that's moles, right? Here's our final answer. Okay, let's look at C. How many molecules are in 100 grams of oxygen gas? Okay, so you notice they give us 100 grams of oxygen gas. We are required to find some number of molecules. What is missing here? Moles are missing. We don't have any moles available, so we are going to convert to moles first and then into molecules. So our statement that is handy, maybe I'll write it up here, number of moles times the molar mass from your periodic table equals your total mass, your total number. Okay, so I'm just going to put a little box around this. If you know these two relationships, you can do all of the conversions that are necessary for this unit. So let's use this top one. That was my bread maker. Okay, so here we go. We'll use this top one. 100 grams is a total mass of your sample. So we're starting here with total mass. We're going to work backwards to moles. So we'll take our total mass, 100 grams, and divide by the molar mass. Now what is the molar mass of O2? We already calculated it. It's up here, 32 grams. So let's divide by our 32.0 grams per mole. And we get 100 divided by 32 is 3.125 moles. Here your grams and your grams are canceling and you're left with your moles. So that's good, moles. But we're not done yet. We need to take those moles and turn them into a number of molecules. So now, here's our total number of molecules, and we have a number of moles, so we can put our number of moles in here, multiply it by 6.02 times 10 to the 23, and get our total number. So let's do that as our next step. We get 3.125 moles, and we will multiply by 6.02 times 10 to the 23. Okay, this is moles, and this is molecules. per mole, right? So our moles are canceling, no big deal. Molecules are left. Okay. Again, you do not have to include the units, but if you're looking in the book and you're wondering how all this business works, I've been canceling them to show you. I had a couple of questions about that. But if you want to leave the units out, that's fine. So we'll take our 3.125 and multiply by 6.02 times 10 to the 23, and we get 1.88125 times 10 to the 24. But of course, we won't leave it there. We need to do our last step of rounding off to the correct number of significant digits and adding in the units. So if you check out our question, 100 has only one significant digit, right? These zeros at the end of the number are not significant unless they're also after the decimal. So these ones are not significant. We guessed about 100 grams. So we want this to be one significant digit long. So here we're going to keep that one. We're cutting it off. Here we're looking at the 8 to go up or down. So we'll round up to 2 times 10 to the 24. And this is a large, large number, which is good because we're counting a number of molecules, right? Tiny little things. Molecules of O2. Okay? Okay. Let's look at number 5. Number 5. It says, how many moles is 80 grams of water? So they gave us 80 grams H2O. We need to find some number of moles. And let's write out our two little statements here that might help us. We have a number of moles times 6.02 times 10 to the 23 gives us our total number. Now this is number of atoms, molecules, formula units, whatever we're counting, right? We also know that the number of moles times the molar mass equals the total mass. So we'll use those statements to answer all of these questions. Number of groups times how many in each group gives us our total, right? It's that same kind of logic. So we've got a mass. This is our total mass of the sample, and we need moles. So we can do one conversion from total mass to moles. We're working backwards, so we'll divide by our molar mass. So let's calculate our molar mass first. Let's put it here, H2O. We have water, so our hydrogen, there are 2 hydrogens involved, each one having a mass of 1.0. There's 1 oxygen involved having a mass of 16.0. So when we add all of that up, we get 18.0 grams. So we'll take our given, our 80 grams of H2O. We will divide by our molar mass, right? So we had a total mass, we're dividing by molar mass to get a number of moles. So we'll divide by 18.0 grams per mole, and we get moles. So 80 divided by 18.0 gives us 4 lots of 4s, 4 repeating, right, moles of H2O. Now here's the thing, we need to know how many significant digits, so we're going to do some rounding off. Here we only have 1 significant digit because that 0 at the end doesn't count unless it's also after the decimal, so that doesn't count. We've got 1 digit there. So here we're going to keep this 4, we're going to round off here. It's a 4, so we're going down. So we just write 4 moles of H2O. Final answer. There it is. Okay, number 6. says, what is the mass of 5.0 moles of water? So they gave us 5.0 moles of H2O. We need to find the mass, so X grams of H2O. We already have our molar mass up here. We're going from moles to grams, so let's check it out. Do we need our molar mass, or what are we doing here? So over in our little corner with our statements that are handy, we notice that we were given moles, okay, but we're looking for total mass, right? So we're going to use this second statement. We'll start with our number of moles. We'll multiply by our molar mass to get our total mass. So we've got 5.0 moles, and we'll multiply by, now we need the molar mass of water. Handy enough, we already calculated it up here, 18.0, and there we have it. So 5 times 18 gives us 90. Now we're calculating grams, so 90 grams of H2O. Let's check our digits. We have 2 significant digits here, and in our answer we have only 1. So we have 2 options. We can either put a decimal at the end, and now we have 2, that 0 will count, or we can convert it into scientific notation and kind of sidestep the problem. So we've got 9.0 times 10, or times 10 to the 1, whichever one you like. Either way, there's only 110 there, grams of H2O. So either this or this, they're equal and acceptable final answers. Okay, number 7. It says use this balanced equation to solve the following problems. I'll write out the equation just so we can see it here together. N2 plus 3H2 produces 2NH3. 7a asks how many moles of hydrogen will combine with 4.50 moles of nitrogen. So they gave us 4.50 moles of nitrogen, which is N2. We need to find some number of moles of hydrogen, which is H2. Now you can notice that there are 2 different substances involved. They're all moles, so we don't have to worry about masses anywhere. But when you're converting between substances and they give you a chemical equation like this, you should kind of ping the fact that you will be setting up our equivalent fractions, right? And you'll want the given up at the given on the bottom. So we'll say 4.50 moles of N2. Helps to have the units in there to organize yourself. On the top, you're required. So X moles of H2. And we'll set up our equivalent fraction over here. The units will be the same, so we had moles of N2 on the bottom, so we'll continue to have moles of N2 on the bottom. We've got moles of H2 on the top, so same thing. But we want to use a relationship that we know about to fill it in and make it equivalent to this one that we're kind of wondering about, right? So our N2 is going to come from here, the number of moles of N2 in our equation, so this is 1. Our H2 is 3 moles of H2 from over there. So what this is saying is that we have 3 times the amount of moles of H2 as we have N2. So you might be saying in your head, okay, well if I take 4.5 and multiply it by 3, you should get whatever X is. And this is totally true. If you want to go that way, you can. These are equivalent fractions just like you've maybe solved before. If you would rather do your cross multiply and divide, totally fine. So let's have a look at that. 1 times X is X, and 4.5 times 3 will go over here. Now 4.5 times 3 is 13.5, and we're looking for moles of NH3. Nope, moles of H2, sorry. Now, how many digits do we need? Well, when we look at our question, they gave us 3 digits. That 0 counts because it's at the end of the number and after the decimal. So if we look over here, 13.5, you've got 1, 2, 3 digits. We are all set. So this is our final answer. Okay. Next, let's look at number B, 7B. Okay. So B asks, how many grams of N2 will combine with 15.78 grams of H2? So they gave us 15.78 grams of H2. We need to find how many grams of N2. So here, we're still basing our question on this chemical equation. We have grams and grams. So that's going to change our question a little bit. This is like your lab. When you notice that we've got an equation and we have 2 different substances, this again should kind of alert you to the fact that we'll set up our equivalent fractions. We'll put our given on the bottom, 15.78 grams of H2, and are required to find on the top X grams of N2. We'll take those units and slide them over because they're equivalent fractions. The numerator and denominator will be the same units. Same as it was before, right? Carried over here. Not necessarily same as each other. Okay, so here we're going to pull these numbers from a couple of places. So we want to find the molar mass of N2 and the molar mass of H2, and we're going to multiply by the number of moles we have in our equations. So for N2, it'll be 1, and the molar mass of N2 is 2 times, from your periodic table we get 14.0, so it's 20, oh, I ran out of space, 28.0. So 1 times 28.0 is what we get for N2. For H2, we have 2 times 1.0, so 1.0 is the mass, and we have 2 hydrogens in there, so we'll double it, 2.0. So that's our mass, our molar mass, and we want to multiply it by the number of moles of hydrogen we need, 3, right? So we can rewrite this statement if you prefer not to put in your multiplication and just skip right to the answer of that multiplication. You can do that. So it would look like this, H2, and here you'd have 28.0 grams of N2 on the top, and you'd have 6.0 grams of H2 on the bottom. And then we cross multiply and divide, so we'll have 6.0x equals, and I'll multiply 15.78 by 28.0. So let me write that out so that we have that. 15.78, oops, 15.78 times 28.0 gives us 441.84. So we'll divide then now to get x all by itself. So divide both sides by 6.0. These cancel, and we're left with x equals 73.64. Let's do our last and final step here. We need 4 digits. We have 4 digits here, so we don't really even need to round it off at all. And we were looking for grams of N2, so grams of N2, and we can just give her an underline Okay,